All right, guys, welcome to the second chapter of this unit. This is on forces. So we are moving away from motion and we're going to move into forces, and then we'll connect the two and their relationships in future lessons. So, what are forces? So I have this image for you guys, and I want you to think about what is creating the forces between these two groups of people, group of one and a group of two. Which direction is the force being applied, and how might the force create motion? Think about that for a second. Well, if we were to look at these two groups of people, we would see that they're both creating a pulling force on one another, and it's being applied in the direction that the rope is being pulled to. So the guy on the right is pulling the rope to the right, and the two kids on the left are pulling the rope to the left. How does the force create motion? When forces are unbalanced, motion will change. Anytime there's forces that are unbalanced, motion will change. So if he is equal strength to these two, then what's going to happen is the forces will be balanced and they're going to cancel each other out. However, if one of the groups are stronger, that group is going to win, and that's the direction that the rope will go. We're going to talk about balanced and unbalanced forces in future lessons. So what are forces? Forces are any two interactions between objects that result in a push or a pull. So in the case of the man pulling the box, he has a rope on the box and he's pulling the box to the right. That's a pulling force and it's applied force. On the right, you have two people kicking the ball. The ball's at rest until the ball is kicked, which is a pushing force, which sends the ball to the other player. And that's how we play soccer. So the definition for force, it's any interaction between objects in the form of a push or a pull. It's a vector quantity, just like acceleration, velocity, so it must have a direction along with its magnitude. And the concept of forces are generally explained by Isaac Newton, who discovered gravity, and Newton's three laws of motion, which we will talk about again in future lessons. So here are two groups of forces and their subgroups. So we have contact forces and non-contact forces. Contact forces meaning two objects are touching, and then non-contact forces meaning two objects are not touching. So take a look at these. We're going to explore these a little deeper. And there's even some like tension force that aren't on here that maybe fall under a category that we're going to explore in future lessons. And there might be a few more of those. So for contact forces, what I have here is I have applied force, spring force, drag force, frictional force, and normal force. For non-contact forces, we have magnetic force, electric force, or electrostatic force, you can call either one, and gravitational force. So how do forces explain motion? Well, whether at rest, traveling at constant speed, accelerating or decelerating, objects move based on the strength and the directions of the forces acting on them. So if I have a person jumping with a parachute, gravity's pulling the object down or the person down, and air resistance, which is blowing against his parachute, blowing upward, creates a drag that keeps him from plunging at a faster acceleration. If I have a person hitting a baseball, the baseball is being propelled forward. It has the momentum until it is hit with a bat, which applies enough force to where it is able to overcome the force moving in the previous direction and actually send it entirely into the other direction. If we're looking at Michael Jackson moonwalking here, when we talk about frictional force. So gravity's pulling Michael Jackson down. He is applying a force which is sending him to the left. However, frictional force is moving against him. So it's not as desirable to do a moonwalk on, let's say, a blacktop asphalt as it is on a smooth dance floor, because one surface applies significantly more friction against that person. So my last question is to you: how about stationary objects? I have two boxes here. Do they have any forces being applied on them? I'll let you answer that yourself. The answer is yes. So in both images, One has 2 forces, the other one has 4 forces. So on the box on the left, I have gravity pulling the object down, a normal force moving against it. Those forces are strong enough that they're equal and they cancel each other out, which in this case keeps the object at rest. On the right, whenever you have forces that are balanced, and in this case I have 2 people applying force in opposite directions, if those forces are equal, those forces are going to cancel out and that object will stay at rest as well. So forces explain motion in unbalanced and balanced terms. So if forces are balanced, the object's motion is not going to change. But if there's any unbalanced force, the object's motion is going to change. We're going to talk about sum of forces or net forces in future lessons. All right, guys, that's all I have for you today. We'll talk next time. Bye.